Good afternoon. It's Tuesday, and this is another episode of COVE Tenant Talks. We're hosted today live from Dartmouth, Nova Scotia. A beautiful sunny day here at the Center for Ocean Ventures and Entrepreneurship. I'm joined today by guest Dylan Wells. He's the general manager of Hawboldt Industries. Welcome, Dylan.
Hey, Kyle. Thanks for having me.
How are things in beautiful Chester, Nova Scotia?
Couldn't ask for a better day. So we're outside testing some equipment today, actually, so it's perfect.
Nice. Sounds like a perfect day for the crew there.
Yeah, thankfully, no remnants from Laura affected us or anything either. So all is good.
Nice. Sounds like you got away lucky there. Your company's been based in Chester for a long time.
Yeah.
Probably one of the oldest ocean tech companies in Canada. When was it founded?
Yeah, we're doing tech before it was sexy. 1906, 100 years ago, actually 114 years ago. So we're founded by a guy named Hawboldt, last name Hawboldt. That's where the name comes from. And as hard to pronounce and spell today as it was then, I guess. But basically started out in the fishing industry, building small single-cylinder engines, for fishing boats. So going way back, we're kind of sort of an entrepreneurial small company with a foundry that evolved quite a bit over the years, but basically always been in the marine industry in some way, going back that long. So.
Wow, right from the beginning.
Yeah.
And still a large fishing community there in the area. So you're very close to your roots.
Yeah, totally. We still have a foundry. We make propellers and shafting for fishing boats, like for the lobster fishery, other fisheries as well. And that's been a part of our business for a long time. But in, I guess probably in the 70s, we started building fishing winches. And slowly, through our proximity to the Coast Guard, being here in Nova Scotia, we evolved fishing winches into more sophisticated winches for going deeper in the ocean, deploying payloads for science and sampling reasons. So we kind of morphed from a heavy duty, call it like a backyard shop type of environment, building winches, for a specific purpose, to a more custom engineering based equipment over a long period of time, say from the 80s into the 90s. And then from early 2000s until now, we've kind of been incrementally growing that product line, the complexity of our products, and really branching into more diverse aspects of lifting equipment. So not only winches, but cranes and really specialized stuff.
That's fascinating. Your company history is so rich. Perhaps we can show that video that you have queued up.
Yeah, sure.
Kind of give people a better understanding of what's going on today and some of the really interesting visuals that you have. So let me get that started here. Sweet. Very impactful video there you produced. Some of the visuals that people saw in there look like some large equipment that you've produced.
Yeah, so you'll see in there our tagline, "Design, Built, Marine," kind of encapsulates what we do. We're an engineering company that builds our equipment here under one roof. So we've got our sales and engineering and a whole production facility, and we've got about 40,000 square feet of manufacturing space, and some big equipment that's required goes out these doors here for different applications in the offshore, workboat, research, defense industries. So that includes things like ROV launch and recovery systems you see in there. So winches and sort of specialized cranes that launch underwater vehicles, work-class ROVs, for example. AUV launch and recovery systems. There's a quick snip in there of some AUV lyres. We call launch and recovery system of lyres. that we sold to Ocean Infinity. Is a pretty big name in the survey side of things for sure. As well as winches that go really deep, like 10,000 meters of wire on them, so very specialized for getting water samples deep in the Pacific Ocean, and ranging from pretty what we would call small stuff. Maybe it weighs a couple thousand pounds up to the biggest. I think the biggest single piece of equipment we have ever made is around 180,000 pounds. So a lot of steel work, and heavy loads, and FEA analysis and testing. That's a big part of it too.
Does it take an even larger crane to lift those big ones?
Comparable sometimes. Yeah. We get boom trucks in, big mobile cranes typically, to load things onto trucks for transport. We don't have a series of larger cranes that, like Russian dolls or anything, that picks them up in the air, but
that would be a sight to see for sure.
Yeah, I don't know if you've ever seen those trade shows where they have like boom trucks lifting a boom truck, lifting a boom truck, lifting a boom. Anyway, we don't have that, unfortunately.
Maybe in the future. Speaking of some of the products you've built, you've also worked on some really interesting projects. Maybe we can start with that and let people know kind of some of the solutions that you're providing to customers all over the world.
Yeah, sure. So one thing we've invested in this year is a new test stand, we call it, or testing grounds for large offshore cranes. So right now we have actually four really big cranes on the order books that exceeded the capacity of our existing testing grounds. So what we did was we essentially dug a huge hole, filled it with over 1 million pounds of concrete and rebar, kind of like you would build at the base of a wind turbine to withstand the overturning moment of these cranes. Because when we test them here, we have to mount them to something fixed in the ground and then pick up a heavy weight at a large radius. And to resist that moment that the crane wants to flip over, you need a big counterweight, or essentially something quite deep in the ground. So that's something we've been working on this year, which is exciting to have in place now. And actually today we're testing a crane which is going to be for the Navy's new joint supply ship, which is built in Vancouver, being built right now at C-SPAN in Vancouver. And that crane is kind of got a bit of firsts for us as well, which is really cool. It lifts cargo on board the ship, which is, I would say, nothing too special, but it's a marine crane. It's designed and built for a marine environment on a ship, but it also lifts fast rescue boat, so like a small Zodiac with people in it, and it has to lift that overboard, deploy it in potentially very rough conditions, including if the ship loses power. So it's got some special systems built in to allow you to safely deploy and recover the boat in rough weather. So the winch is really specialized, actually, to go very fast. So if you can picture launching a boat into the sea, the waves might be making the boat go up and down quite a bit, and the larger ship might not be moving as much. So you have this differential motion between the ships, and the winch has to react really quickly to keep the line from going slack, or else it can be quite dangerous. So it's called a constant tension winch, but that's sort of a new, we're building 40 of those actually right now, and that's the first one we've really put through the full paces. And secondly, when the ship loses power, you need to be able to deploy this for safety, safety of life at sea reasons, just shipboard requirements. So we actually have an energy storage with hydraulic accumulators that allow you to move the crane outboard and deploy this boat without any electrical power on the ship. So it's sort of a fail-safe system to ensure you can get that overboard.
Nice. That sounds like a very critical piece of infrastructure for the Navy.
Yeah, it's they should be heavily used. There's 3 cranes on the JSS, 2 of these and 1 main cargo crane. And the main cargo crane is typically used for loading and unloading the bulk of what JSS carries, but these are for some smaller applications and probably be used a bit more frequent. Well, they'll be used a lot. Certainly, they're critical. And yeah, sorry, go ahead.
No, go ahead. I was just going to say, kind of fascinating visual to think that just the rough sea states being able to kind of assist in those rescue or deployment issues is very important.
Yeah, it's a unique, well, not unique, but it's a challenge for marine cranes, and especially for this type of application. The requirements are quite extreme. The ship, in that type of a condition where it's an emergency, might be under sort of a severe list and trim or roll and pitch, more so than you might typically expect to operate in. So the requirements for this type of a crane are actually a lot more severe than even a normal offshore crane. And I've got a couple pictures actually from yesterday on the test stand. Maybe I could show you of the crane, just talk through quickly.
Yeah, for sure. I'd love to see that. It sounds like testing of something like this would be kind of challenging in a zone sense to validate these assessments.
Yeah, it's sort of a customized test for sure, just for this crane actually. So can you see my screen there?
Yep, looks great.
Yeah, so it's a little bit hard to tell what's going on here maybe, but this is the crane here mounted onto an angled test base. And what we're trying to do is simulate that pitch and roll motion of the ship. So you have to be able to move the crane kind of uphill almost when you turn it with the load. And the best way to simulate that is with an angled test base. So you're fighting against gravity the same way you would be if the ship was rolled over at 20 degrees. Here's another angle from behind, so you can see Chase, our design engineer there, is just kind of halfway up into the control pedestal. It's not really a comfortable angle to control from, so there is a remote electric over hydraulic controls as well. But it's definitely a weird sight for us compared to some of the more normal marine cranes that don't see this extreme of an angle. It feels shocking to me, probably just looks kind of normal to someone who's not used to seeing these things. But here, another picture you can see, sort of what I'm framing right now is the hydraulic power unit that runs it. Got this pretty little tarp hung over it. Unfortunately, when you test these things, you don't do the final permanent wiring, so you leave the panel open a little bit, typically to run the power feed. So that was protecting it from Laura on the weekend. Anyway, and this is the accumulator stand, so that's where we store all the energy that lets us do one cycle of the crane's motion without any electrical power. So it kind of looks like a bunch of pressurized air bottles almost, but they fill with hydraulic oil. See, I guess this one last picture, just to talk about it quick, is the crane sort of at full extension, left up a fair bit, picking up the max. So we do overload testing. A big part of what we do is making sure everything's set right, everything functions as it's supposed to. The crane sees the maximum load it should ever see at our factory, per the rules that we designed to for shipboard rules. We test, like this test is 25% overload kind of thing. So the crane should never actually see this again. So we're picking up about 16,000 pounds there. That's a big steel weight. Yeah, so we run through all that stuff with our customers here, and they get to operate it, make sure it, the fit and finishes as they expect as well. And it's pretty fun, I gotta say.
Would this typically be one of your larger cranes, or what kind of, in what range would it be?
This is maybe a medium size. Yeah. So the crane itself weighs around 30,000 pounds, thereabouts. And it lifts 6 tons at around 10 meters. It's kind of its capacity. Maybe I'll stop sharing that for now.
Perfect.
Okay.
That's exciting. That project, you must be very excited for that to go forward, and you're going to keep you guys busy for quite some time.
Yeah, it's really, like I said, been a couple firsts for us, which is exciting. It's always a little bit nerve-wracking. The winch, I guess I didn't talk about it too much on there, but as I mentioned before, it's fairly specialized. And we've got a really large order for the Halifax-class frigates. They're doing some upgrades on those ships for the Canadian Navy. And they are putting new, called them mission boats, but essentially like Zodiacs, on there, and new cranes to launch those, as well as a crane on the other side of the ship for more general purpose stuff. So each Halifax class frigate is getting 2 cranes, kind of similar to that, but a more compact version with basically the same winch and a lot of the same requirements. And so we're building 30 cranes for that contract, which is underway right now, and has a few new kind of different requirements as well, because it's a warship. It's a frigate, not the supply ship. Any critical systems on those ships actually need to be shock tested, which means they need to be tested and proved to be able to survive a major shock event like a torpedo strike on the ship. So if you were testing a piece of electronics, it's not too difficult to do shock testing. There's a lot of different methods depending on the size of what it is, but when you're testing a crane that weighs 20,000 pounds, it's a little bit more difficult, because you have to have a lot of energy to shock it correctly. And so one thing we're going to be doing is sending these cranes to a shock facility where they mount the crane to a barge in a small lake, and they detonate around 50 pounds or so of TNT under the barge, essentially make an explosion at the right distance away and violently launch the barge, I wouldn't say into the air, but shock it severely. And then the crane has to function afterwards to prove that it can survive that impact. So we haven't done that yet. Like I said, this crane didn't need that for JSS, and something we're pretty excited about in a sort of a nervous way, I guess, of doing. It's a little bit of a new thing for us, and there's lots of simulation you can do in advance, but really it's the test that's important. So
I would love to live stream that if we can.
Yeah, us too. I don't know about live, but
put it on tape delay just in case.
We're pretty excited to get up close to this test, but with COVID, it's changed things a little bit. So.
And you said those tests are not done here locally, so I guess you couldn't travel with it.
No, the crane. There's a couple facilities in Virginia and one in Scotland. There's nothing in Canada that will do this type of explosion test. The Canadian government has a few facilities for smaller things, but they don't do the blowing up tests. So
interesting for sure. That's a fascinating visual, and hopefully we get to see some pictures from that later on this year.
Yeah, for sure. I'll definitely be posting them on my LinkedIn.
For sure. That'd be fun to definitely see that. So if anybody's watching that wants to see that, just follow Dylan on LinkedIn and Hawboldt. They have lots of good content on there, lots of videos and behind the scenes stuff on there as well. So flipping from the defense side, I know you have a really interesting project with the University of Hawaii. Maybe you want to jump into that.
Yeah, sure. So one of our core product lines is ocean research winches, or ocean science winches. And this year we delivered a system with a 10,000 meter active heave compensated winch. It's used for CTD sampling, so taking water samples at various ocean depths to the University of Hawaii. So they operate mostly in the Pacific Ocean, and so they operate great depths, and 10,000 meters is kind of a big round number standard. And so we delivered that winch along with a specialized crane, sort of a multi-purpose custom-built crane that operates together with the winch, which is a little bit abnormal. Oftentimes, you don't see cranes used for deep subsea applications because a typical crane might not actually be designed for the type of loading you'll get from that winch application. So you might get a lot of off lead, side lead angles pulling on the crane on the boom that it's not designed for. So in this case, it was purchased as a system and designed to fit in a very tight space on the vessel actually as well, and provide a very specific range of motion for them. So we built that system, I guess, last year, shipped it around the start of this year, and ended up commissioning it in person on the West Coast during COVID, and doing a lot of our commissioning remotely, which is kind of interesting too. So we're able to log into our equipment over the internet, watch what it's doing, actually operate it as well if the customer is willing. And the vessel this is on, they do tons of work. They're busy all the time, and their cruises are really critical that they happen with regularity. So there was some anxiety about how that might get impacted with COVID. And it was cool. We were able to do a lot more remotely than they ever imagined we could do, actually, in starting it up and monitoring it. So that's working now, ongoing. It's like I said, a complex deep water active heave compensated system. And for us, the big thing is how it's integrated and works together. Two pieces of equipment that sometimes on ships are made, or oftentimes I would say made by different suppliers and not actually designed to work together. So there's interlocks and things for safety and to make operations more simple that this does, that it is operationally a huge benefit for the customer. And they're finding actually they're cutting down their actual time to do the science by about 50%, which is amazing. So it can have a huge impact on the ship availability, how much they can do days at sea, even for cruises. So cutting down on their total cost to gather the data, and it's really interesting. So I got a couple pictures of that too I'd like to show.
Sure.
Quickly.
That's fascinating, though. I didn't know that I thought they were just mechanical beasts, but it sounds like kind of like a smart crane with all the tools and features of like an IoT device, which is kind of interesting. Yeah,
I mean, there's a pretty complex control system for all this stuff. Like I say, a lot of interlocks. It's heavy equipment. It's dangerous. So you want to make sure that you've got the right safety systems in place. And when it's supplied as a package, you can actually make that more robust too. So you can see my screen here, I guess. So here's the winch on the deck of the ship. It's a little bit hard to tell what's going on, but this is leading aft. I like this picture because it's a pretty sunset. This is sort of on the first commissioning test cruise, and this wire would be going to the boom tip of the crane and then into the water and down thousands of meters. Let me go to the next one here. What do we got? So here's kind of a view of the operator control stand, and this is the crutch that the crane would rest in when it's not being operated. And here's sort of the main boom of the crane and the knuckle boom, and the boom tip goes way down to the water. You can't even tell where it is right now, but that was something that was specialized for this vessel because they wanted to get the tip really close to the ocean, so when they pull their package out of the water, it doesn't have as much pendulum to swing before they get it kind of recovered. So sort of a standard product customized a little bit for them. Here's a better view of the whole crane, I guess, and this is a CTD rosette on the end. I think it's a 24 bottle rosette, so it can take basically 24 different samples of water at different depths. And our engineer and a bunch of the crew just doing some training. So because these systems are complex, we offer a lot of operator and maintenance training too. It's kind of a big part of getting a system started up, making sure everyone knows how to use it correctly, safely, optimally. Yeah, so there it is, kind of stored, tucked in tight. The center line of the vessel is over here, so this is really not taking up much space on the ship. It allows them to do a number of other things with some other existing gear that they do, and giving them a lot of flexibility with this kind of crane design that's a knuckle boom with an extension onto it. So we're pretty proud of that project, and we know the customer's been really happy with it, and look forward to them using it for another couple decades, kind of thing.
Nice. That is that's pretty cool. I think we have a video of it in motion too, right? The same crane.
Yeah. So we put together a little video during our FAT. Probably the only time this thing's ever going to see snow, as we tested it around Christmas, and kind of shows it working together a bit.
Perfect. So I'll cue that up and play it. Awesome. Some great visuals there from your plant in Chester, Nova Scotia.
Yeah.
We're quickly running up on time, but I do want to touch base quickly on the value prop of Hawboldt, which I think is all-in-one roof, kind of all-in-one solution. Maybe you can kind of dig down a little bit into what makes Hawboldt unique in this space.
Yeah. So we're focused on being a single stop, sort of a solutions provider for the whole ship for deck equipment. So when someone's building or speccing a new research vessel and they're trying to figure out what kind of equipment they need to get their packages in and out of the water, Hawboldt is a winch maker, we're a crane maker, we make specialized launch and recovery systems, and we do the integrated controls for the whole system, ship-wide, and all of that is designed and built here in Chester. So that's pretty unique, actually, in this industry. So we're focused on niche applications where we take a fairly standard product line and customize it for the end user's needs and give them a safer and more efficient operation, kind of like I talked about with Hawaii. And so instead of trying to interface with several different vendors, make requirements match, it makes the actual shipbuilding easier for the shipyard, because there's a single contact for integration, and it makes the life cycle cost a lot lower for the ship owner too, because the stuff is designed to work together. There's a single system trainer, maintenance provider, and it just streamlines the whole process. And the capability we have here at Hawboldt to do all that in one factory is actually pretty much unmatched. Most of our competitors, who there are not a lot of, have different sites. There might be much larger companies that kind of dabble in these different niche parts and have more of a standard product, and they don't really integrate it that well. So for us, it's key to explaining that to our customers that when you buy something from Hawboldt, you're not just getting a great piece of equipment, but you're getting that one-on-one with our engineers. You're really working together as a partnership, and we listen and give good feedback both ways, and it's a conversation. And we think that's really important in providing a good system that's designed exactly how it's supposed to be and operates just the way they want it to be. So
that's great. That's a huge value prop that I think goes a long way in building kind of those long-term, long-lasting relationships.
Yeah, that's right. And it's interesting you say that, because we're we're definitely focused on that, on the long term. We've been here for a long time. We will be around for a long time. The equipment is a huge investment, and so you have expectations as a customer that it's going to last and operate well over the long haul, and I think we have the track record to show that already, which is great.
Awesome. Look forward to hosting another episode with you 100 years from now. Through holograms.
Yeah. We'll be the heads in bottles.
That's right. That'd be great. We have the little cranes to move us around. It will be the new business model. We're quickly beyond time now, but I really appreciate Dylan for sharing more about Hawboldt and your history and all the cool projects you're working on. So thank you very much.
Thanks a lot, Kyle. Really appreciate it.
So we do this every week, and next Tuesday I'm joined by Seamus McDonald. He's the CEO of Sedna Technologies, and they're doing some really cool stuff on the IoT side for fisheries, seafood, aquaculture. So looking forward to that. And again, Dylan, thank you very much for a very fun discussion, and I think everyone learned a lot along the way. So thank you again.
All right. Take care.